Hello students. Today I am going to discuss about how to build a low-cost COVID-19 thermometer by yourself. As you can see on the screen, you will be able to get the temperature reading directly onto a PC screen with a small graph. Now, in order to build this yourself, what you need to buy is a sensor which you can buy from Amazon. I bought it for 1000 rupees, which you can mount it on a stand where you can move it upwards and sideways. The idea is to place your hand in front of the sensor. Then and there the temperature will be displayed in a bigger font in a computer screen. Now the sensor, as you can see on the screen, is a four-legged sensor. It has got 4 pins, and the pins are called SCL, SDA, PWR and GND. PWR and GND are the power pins which you can power this sensor by 3.3 volts. SCL and SDA are serial I2C communication pins. Those who are familiar with interfacing, they can easily figure it out. And this sensor is a popularly known sensor. It is called MLX 90614, which is an infrared sensor. So the microcontroller which is required to be used to interface this sensor can be of different types, but I always prefer the ARM based MBED compiler. There are some people who prefer the Arduinos, but I always feel that this particular ARM MBED microcontroller families are more powerful, and here the firmware has to be written in C++, and it looks very future promising. So as you can see on the screen, the microcontroller is placed at the bottom, small microcontroller, and one end of the microcontroller is connected to the PC, and power to the entire system. You don't need any battery or anything like that in the system. The power is coming from the USB itself. And there's a small wire running between the microcontroller and the sensor, which carries the 4 wires. The 3.3 volt is automatically generated from the USB by the microcontroller. Very stable voltage which you can feed directly as the sensor power. Now, the connection diagram looks like that. Pin number 27 and 28 you can use for the I2C communication, and you can use ARM MBED compiler with this. This microcontroller is LPC1768. You can create a binary file out of your C++ program, and that can be downloaded into the flash to start working. And the sensor details, as I explained earlier, the bottom view looks like that. And when you buy a sensor MLX 90614, you can buy more expensive ones, more accurate ones, and which are very suitable for medical applications, etc., etc. But the sensor has got a disadvantage that its if you place your hand just in front of the sensor, the distance of your hand from the sensor front, the distance really matters. You have to be very close, within a centimeter or so, to get very good accurate readings, stable readings. If you go further away, there is a gradient, the temperature is shown reduced, because the sensor works on the heat flux which is transmitted into the infrared window, which is inversely proportional to the distance. And this is how the final setup looks like. So the firmware what you built is able to transfer the data through the serial port, nothing but the USB port in this particular case, and USB port will be mapped as a COM port, and that COM port you can read it right through LabVIEW program, as you can see, and you can even put a cutoff that 32 degrees or whatever is above that. You can give a red indication, and you can also get a graph on the screen, etc., etc. Now, in order to do this particular project by yourself, you need to watch some more of my videos. One will be for the LabVIEW programming for this particular purpose, the other for the ARM MBED firmware programming. So before you get into watching my next video, just look at my other videos where you will get the basics of all these two, and further reading you can also refer to this. Thank you.